Assalamualaikum and a very good day I bid to everyone. My name is Afiq. Today, my team members and I will present to you about interference testing in well test analysis. First of all, what is interference testing? Interference test is actually a type of multiple well testing. Before we can proceed further, we need to know a few things about multiple well testing. Lucky for us because I have prepared a handbook for us to know further about multiple well testing. Multiple well testing has large radius of investigation. It also requires one producer and observation well. It is not affected by skin because skin only affect neighborhood of active well except fracture well with high negativity skin. Well bore storage effect is maximized in multiple well testing. This is the producer well and this is the observation well. The producer well can either be producing or injecting. Meanwhile, observation well will be shut in and there will be no production in this well. The distance that separates these two wells is denoted by R. And now, let us take a look at the objectives of interference test. The objectives are to determine the reservoir connectivity. The second objective would be to determine the directional flow pattern. The third objective is to determine reservoir porosity. And last but not least, it is to determine the nature and magnitude of an anisotropic directional reservoir permeability. And now, I am going to pass the floor to my friend Aqil for further explanation.
Alright, thank you Afiq. Hi everyone, my name is Muhammad Aqil and I'm going to explain further about interference tests in multiple well testing. Okay, firstly, there are two different cases while conducting interference tests. For case 1, the data from observation well is taken when the active well is still producing or injecting. Next, the pressure at observation well can be calculated using this formula. PWS, which stands for pressure at stabilized well pressure, equal to P1 hour, where pressure at time 1 hour, plus M, the slope from the plotted graph of semilog, times log T, where T stands for time. For this formula to be applicable, there are conditions need to be met, where 0.0002637 times K, the permeability, times T, the time, over porosity, times mu, the viscosity, times Ct, total compressibility, times R square must be greater than 100. So to calculate this value, we must first plot a semilog graph using the obtained data, where P against time. From this graph, we should be able to obtain the slope of M. Next, we can obtain the porosity and permeability from the plotted graph. To calculate permeability, we use the formula of K equal to 162.6 times the flow rate Q times viscosity mu times formation volume factor B over M, the slope of the plotted graph, times H, the height. So for porosity, we use the formula of porosity equal to K, permeability, over mu, the viscosity, times Ct, total compressibility, times R square, exponential of Pi, which stands for initial pressure, minus P1 hour, where pressure at time 1 hour, over m, the slope of the graph, minus 3.2275. Now we have all the value you need. We have the permeability, K, and the porosity. So we calculate the value of 0.0002637 times K times T over porosity times mu times Ct and times R square. If this value is greater than 100, then only we can use the formula of PWS equal to P1 hour times M times log T. For P1 hour, we just take the pressure at time 1 hour, and the M is the slope of the semi-log plot. And that's how you find the stabilized well pressure PWS at observation well after a time T. Now I will proceed to my friend Fikri for explaining the case too. Thank you very much.
Hello, my name is Fikri. I will be explaining the second case for the application of interference testing analysis. In case 2, the active well is shut in after the producing time. So, if we want to find out the permeability and porosity of the well, we will have to follow these simple procedures. The first step is to determine the pressure behavior of the well. By using this equation, pressure is equal to the initial pressure plus the product of the slope m and the logarithm of production time plus change in time divided by change in time. Then, we have to plot the graph of PWS against this whole thing on a semi-log graph paper. Our graph should look like this. Next, we can calculate the slope m by taking some values from the graph and substitute them into this equation. After finding the value of the slope m, we can substitute it into this equation to find the permeability, whereby K is equal to 162.6 multiplied by flow rate, viscosity, and formation volume factor over the slope m and the thickness of the formation. Porosity is then can be found by dividing the permeability that we have calculated in step 4 by viscosity, total compressibility, and the squared radius, multiply with the exponent of pressure at 1 hour and the PWS taken at time equals to 0 divided by the m, which is the slope we have calculated in step 3, minus log of 1 plus 1 over production time minus 3.2275. That's all. Next, my friend Fadzli will elaborate and explain more on the application of interference well testing analysis using log-log type curve. Thank you.
Hello everyone, I am Fadzli. Now for my part, I will be explaining on how to do interference test using log-log type curve. Basically, there is 4 steps to calculate permeability and porosity with interference test. What we need to do is, we need to construct the table of delta T, time, and delta P, pressure. Sets of data will be provided for delta T, and we need to calculate delta P using this formula. Delta P is equal to initial pressure minus bottom hole flowing pressure. For the first step, after all data are complete, we can now plot the graph of delta P versus delta T on the log-log graph. It would be easier if we draw the graph on the tracing paper. So, for the second step, we can now match the point on the master curve with the plotted graph. While matching the curve, we also need to adjust the graph to the master curve. The scale and the size of the curve need to align perfectly with the master curve to obtain the best result. As you can see here, this is an example of the interference test analysis type curve matching. Next, for the step 3, after the points are matched, we will be able to obtain match point from both of the graph, which are delta P, delta T, dimensionless pressure, and dimensionless time over dimensionless radius square. And finally, we will be able to calculate permeability and porosity using this formula. Permeability K is equal to 141.2 times Q times B times mu over H times dimensionless pressure over delta P. For porosity is equal to 0.000267 times K over R square times Ct times mu times T over dimensionless time over R dimensionless R square. When calculating the porosity and permeability, you might get a different value than the other. It is because each person picked different values for dimensionless pressure and delta P, as well as time and Td over Rd square. Now, I am going to pass to Hamizan for further explanation.
Assalamualaikum and hi everyone, I am Hamizan. So, I will help you guys to solve one example on interference while testing. First, let's take a look on the question. On the question, two tables of data is given which consists of all the value we need to solve for permeability and porosity. On the interference test data table, which consists of time and pressure, both start at 0. We can ignore these two values since we are going to plot on log-log graph. Next, last point in given pressure data is stated as n. We can also ignore this data because we cannot plot it. So basically, we will only plot 4 out of 6 points for this example. Let's solve the example step by step. Step 1. Plot the graph of delta P versus delta T on log-log graph. By plotting all the data given, you should get a graph like this. This is delta P and this is delta T. Next, we can proceed to step 2. Step 2. From the plot, match the field data to the master curve. As explained by Fadzli before this, in this step, we should adjust the plot with the master curve. We have to make sure all the points lies on the line in the master curve. So, when adjusted, it will look like this. After aligning the graph accordingly, we can proceed to step 3. Step 3. Pick the following matching point from both field data curve and master curve. Here, in this example, I pick the intersection point from graph that I plotted, which is in this region. From the point, we can obtain these values. Delta P equal to 100, T equal to 10, PD equal to 1, and TD over RD square equal to 0.85. Next, we will proceed to step 4. These 4 values might be different from others, but you don't have to worry about it. Take this point and proceed to step 4. Step 4. Calculate permeability and porosity using following formula. Using given formula, we just have to key in all the values needed. For permeability, the formula is 141.2 times Q times B times U over H times PD over delta V. When we key in all the values, we will get the value of permeability equal to 5.33 millidarcy. Next, we can calculate porosity using formula of this. Porosity equal to 0.000267 times K over R square times CT times U times TD over RD square. When calculated, we can get the value of porosity equal to 0.092, or we can change it to percent, which equal to 9.2%. So basically, we have solved the example using all the steps explained earlier. Well, that's all for our presentation, and thank you for watching.